Okay, hello and welcome to my experiment 5. So the experiment 5 is the data transmission through keypad. So apply the order 3 and 4, understand the instructions, control set, the keypad, and demonstrate how the keypad works as well as with the other peripherals. So first, this will be what they call this, the map, the keypad map. So in order to do that, we will right click this. So let's change the label. So I'll change 10 9 uh, 10 9 8 8 8 5 4 3 8 7 6 4 3 2 then 0. So here we have modified our keypad. So this the press number will start at number 0. Here it is. Here it's and then this however, this press number is found valid. There you start. So let's type this code. Excuse me.
Ako na.
What's the big?
Hindi.
So let's say this. So let's call this 5 part. Let's say that's a sample and that's so Okay, let's go to the instruction. So speed output, choose 100. Okay. So press T. Okay. So let's answer question. So let's try. Let's press E0. So R0 is 0. 0. So I will modify this status. Okay, so it's working. So okay, R0 is on. Let's click 2. Hold on a second. Okay, so after testing, so the program will, the R0 will count and will increment indefinitely and until I press a button. So that's when will we get a value. So if I press 2, it will stop at 2 and I will not be able to change this unless I reset the program. So let's answer this one by one. So 0x02, sample and run 03 for 0x03, 0x03. Okay, let's do 4. So it stopped at 4. So x04, excuse me, 0x05. I believe here 6, 0x07, 8, x09. Okay, so I believe this will be the case. So since those are the normal numbers that we usually count. So if we reach 9, 10. Okay, so let me reset this first. So 10, so it will become a, so XA, because this the hexadecimal of 10 is A. So let's check for B. Reset. Let's press 11, symbol and run. It will go B. So that's it. So it follows the hexadecimal counting. Starting from 0 up to B because we only have 11 keys right here. So okay, part 2. Okay, so that's for part 1. Okay, that's for part 1. Now for part 2, split the table below. So let's create a new file. Let's save it. Okay, but with a new instruction. I believe there's a new instruction here. So in the subroutine got key, change jump dollar sign to jump start. So change dollar sign to jump start. Okay. So the subroutine between F0 and return is at this. So let's copy paste. Okay. Okay. So with that, click save, assemble, and answer the questions. Let's run. Okay, so let's run it first and let's look at the display. So okay, so we have 000. That is LED output display. So I'm not sure if we are going to use this complemented version or the uncomplemented version. So let me check. Okay, so going back to this, so we can see here these are the 7-second displays. So P0 to P7. So the answer for that question will be uh, number sign 1 2 3 4 5 1 2 3 4 5 6 7 8. Okay, that's it. So because we have here a dot, we consider also the dot. uh, so let's reset, let's click on. So here we have 0 1, so we have 0 0 0 0 0 1. So basically the binary combinations. So I believe it will be that. So this will be 1, this will be 1 0, this will be 1 1, this will be 100 100 110 123. So 0, and then 1 1. So for checking, let's try some numbers before moving to the next question. So let's click 10. So here we have 0 0 0 0 1 0 1 0. So that's for 10. 0 0 0 0 0 0 0 0 1 0 1 0. And let's try 7. So let's try clicking 7. We have 0 0 0 0 0 0 0 0 0 1 1 1. So that is 0 0 0 0 0 1 1. So we have 1 2 3 4 5 6 7 8. 4 5 6 7 8. So we have 8 bits right here and 8 bits right here. So the output display is in binary. So what is the output program? Get at least 4 samples and illustrate a picture or a drawing with an explanation. So that is, oh wait, but I think I answered the wrong one. Okay, so for question 1, let's look at it again. Oh, so this will be added later. So let us display. Oh, wait. Okay, so going back to our question 2, I think I accidentally. Okay, so I haven't pasted it yet. So, yeah. So what instruction and where should be added to display the correct output? So uh, following the previous usage of the 7-second display, so the 7-second display actually uses the complement of the input as its output. So here, that's why, as you can see here, our input on the ports 1 to 1.7 are 0, let's say 0, 0, 0, 0, 0, 1. So as you can see, it is complemented. So here, one instead of 1, the output is here is 0. So we just need to take the complement of A before moving to P1. So let's add your CPL A. And I think that will be the answer for that. So let's see. Let's enter 9. So 9, binary of 9 is 1001. So we now have the correct output. So let's answer the question. The code to be added is CPL A between move AR0, move AR0 and move E1, let's say E1 A. This is to complement the input because the 7-segment display takes the complement of the input for displaying it. So there. So after the changes, we did part 2. So we will just be complementing this. So let me just paste this and let me complement this one by one. So we will have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6. Wait lang. So this is this will be 0, 0 and 3, 4, 5, 6. Okay, so this will be 0, this will be 1, 2, 3, 4, 5. So this is 0, 0, will be 1, 2, 3, 4, 5. This is 1, it is 1, 0, 0, 1, 2, 3, 4. So let's see. For the 6, let's enter 6. Oh, no, that is right. So here we have 7, 1, 2, 3, 2, 3, 4, 5, 0. So just do double check, which is 0, 1, 1, 1, 1. Okay, 0, 1, 1, 1, 1. So this will be 0, 1, 1, 0. 2, 3, 4. Maybe 1, 0, 1, 0. Okay. Okay, so let's see. Okay, I think everything is correct. So 1, 0, 1. So let's try 1, 0, 1, 1, 0, 1, 0, 0. Okay, so that is the answer for our question 3. For question 4, let's start the program. Give these 4 examples. Or or with the drawing. So let me just take a screenshot of this. This is for output 11. So we will be pasting horizontal. So I will, of course, modify the picture, the submission. They call this the document file later. So sub 4. And how many pictures that? 1, 2, 3, and final one. So let's try 6. Okay, so that is for my question 4. So why do we need to clear the general purpose flag 0? So to answer that, how about let's try it here. Excuse me. Excuse me. Um, F0. Where is F0? J. Okay, so hold on a second. Okay, so if we look back on our part 1, so here in the part 1, there is no clear, so we just set F0. So F0 receives a flag, uh, so it will be set as true if we detect a input pressed on the what they call this, on the keypad. So the importance of clearing this is, as you recall, as we performed earlier, on our part 1, it did not actually uh, check any more of the inputs that I made. So how about let's do that. So let's save it, part 2, yes, overwrite, yes. So let's open our old file. So here in our old file, there's no clear, so we just set it. So let's assemble and run. So if we click 9, of course it will read 9. So there's a 9 in our R0. But what if I wanted to click 11 in the same running instance? So here I'm pressing 11, but the R0 is not being updated. So because the set state right here means that we only detect an input once, where in case if we clear it, we can detect multiple inputs in one running instance. So no, let's load R75. So as you can see right here, we set B to F0 and clear it to S, and we clear it after what do you call this? After moving the values from the register to the display. So if we assemble right here, run, let's click 9. Okay, there's an input, and if I want to run, if I want to click 0, then this must be 0. So as you can see, we can click uh, the keypads multiple times in one running instance without resetting the program. So that is the importance of that. So let's type it in. If F0 is not cleared, it means that the program will only detect an input once. because it is a general purpose lab that is used to trigger uh, that is used to trigger whenever an input is received from the keypads. This is the case in the part 1 of the experiment where if where only one input is detected on one running instance of the program. When the user decides to press a different button, the program will not read it and will keep the very first what they call this the very first input it received, compared to part 2 where where it is where F0 is here. The user can press different buttons at a different time in one running instance of the program while still providing the desired output. So that is answer for my question 5. And I think that's it. So the remaining will be discussion and conclusion. So I will type that later. And so yeah, I think that's it for my experiment 5, which is the what do you call this? Data transmission through keypad. And thank you for watching.